Good afternoon. How's everybody doing this afternoon? You ready for a little bit more? Or are you completely saturated already? Got room for a little bit more? All right. Okay, good. Glad to hear it. Last session of the day. We'll hopefully keep you awake and interested. So good afternoon. I'm Dan McLaughlin. I'm a Principal Program Manager lead for the graphics team as a part of the operating systems group. I've been with Microsoft about 8 years now and been in the graphics industry for close to 30. So I spent about 18 years here in the Bay Area working at companies like Silicon Graphics before I moved up to Microsoft in 2006. I led the D3D team and the building of D3D 11 in Windows 7. I then moved to the PM team and worked on D3D 11 from the PM side on Windows 8. And I then moved to the 2D team, and I'm responsible for basically everything in the graphics stack above D3D now as a part of 8.1 and beyond. So today, it's my privilege to talk to you about some of the innovations that we've done in high-performance 2D graphics, in particular around DirectX and the platform for both Windows and Windows Phone. So with that, we'll give you a little bit of a roadmap of where we're going to go today. First of all, I'm going to spend a little bit of time and talk about the convergence between Windows and Phone and what that means from a DirectX perspective. You heard about this in the keynote this morning with universal projects, and so we'll bring that a little more specifically to what that means from a graphics perspective and from the graphics stack. Then we're going to talk about what's new in capabilities across those unified platforms for 8.1. That's both within 8.1 Windows Phone and the update for Windows. And we'll talk about sort of three topic areas. We'll talk a little bit about text, a bit about geometry, and then finish up with some imaging. So how many of you are familiar with DirectX? Written DirectX code? All right, good. So DirectX is the foundational technologies from a graphics stack perspective that everything within Windows is built on top. So if any pixels that are on the screen is going through either a DirectX driver or through the graphics stack. So it really is a place that we spend a whole lot of time thinking about performance and making sure that it's tuned to give you the best experience possible on Windows and Windows Phone. And we also expose that same technology to you as developers to be able to have that same power at your fingertips to be able to get the best performance out of the hardware. So if you really want to get to that best performance, then the DirectX stack from a graphics perspective is the place you want to be. The top or upper levels, think of, from my perspective, upper levels is anything that sits on top of us, right? So that includes IE, that includes XAML, that includes Office, and all of the other things that we build within Windows. All of those things expose portions of the graphics stack. And so you're actually getting the acceleration through DirectX, even in those platforms, right? So IE, Internet Explorer, is built on top of DirectX. Office is built on top of DirectX. The XAML platform is built on top of DirectX, and all of those other technologies. So we really are foundational, and you'll see all those kinds of things be exposed through those layers as well. So let's talk a little bit about what convergence means, or what you've heard about in sort of these universal projects. First of all, from a Windows Phone perspective, in Windows Phone 8, the only thing that was available from a DirectX perspective was the 3D portions of the DirectX stack. With Windows Phone 8.1, we now have the full 2D stack, image effects, and DWrite, which is the foundational thing to be able to expose text, and that's tied very closely with D2D as well. Secondly, the universal Visual Studio solutions. You heard a little bit about this in the keynote as well. This allows you to write your app once, take the assets that you have from Windows or Windows Phone, and be able to migrate those so that you can actually have them on both. Share a lot of common code, and then be able to have separate things that, as necessary, for the different components where you want to do something unique for each particular platform. In particular, you may find that there are certain assets that you want to have differently, or that you might want to tighten up parameters or change the way the layout of your user interface looks to that. So with that, hello, there we go. One of the other things that we in the graphics team have done in conjunction with some of our partners across the Core OS team is that we've spent last couple months, taking and looking at all the samples that we have on MSDN from 8 and 8.1, and we've moved the top samples to be on top of this universal solution. So you'll be able to go, and I just got mail a little while ago that those are live on MSDN. So if you go to MSDN, there's some of the samples that I'm going to show you and some of the demos. All of those, some of those, and I'll point out which ones, have actually been converted to be universal projects. So you can go pick up that code, take a look at it, and go build it and run it. With that, I want to show you one of those samples. Let's see. We're going to go here first. Yes, got the right one. So, how many of you have seen this sample before? Anybody seen this one before? Oh, good, a couple of you. So this is a 3D sample that includes 3D text, imaging, audio. It allows you to use DirectX, the Xbox controllers, uses touch input and also mouse and keyboard, and so it allows you oh, you can't see the box to your left. I think that's right. Yes, your left is the move controller, and the one to the right actually allows you to fire. And then if you touch, for some reason my touch visualization doesn't look like it's working here. You actually get to move around and then be able to shoot from the bottom corner. So this sample was we actually ported and moved to the universal samples. So now I'm going to flip to input 7 here. And this is a Nokia 920 running Windows Phone 8.1. And this is exactly the same code. So you can see it's on this phone, and I'm also projecting through the device, my device here. And we can do exactly the same thing. Same code running on both devices. So what does that look like from a Visual Studio perspective? I'm going to flip back to here. The right one? Whoops. Wrong button. There we go. So this is the Visual Studio solution for that same sample. You'll notice on your right, the column, you'll see there's 3 portions to this. This solution has 3 different sets. So there's the solution, and it has 3 projects within it. The bottom portion, which is the shared portion, has 99% of the code for this sample. So there was very little that we had to do that was unique to each of the form factors. And the way to think about this solution is that the shared piece plus the piece that you're building at the time, so this is the Windows or the Windows Phone portion, the Windows piece and the shared piece get pushed together and compiled, or the Windows Phone piece and the shared piece get pushed together and compiled, right? So you'd have common things, or that the linkages need to be hooked up to be the same. So if we expand the Windows and Windows Phone portions, you'll see down here we have there's one class and one include file, which are different between these 2 projects. Everything else is the same. And so what you see on your left-hand side, this is the phone. This is the window. The far left is the Windows version, and the middle part is the Windows Phone version. And basically, what we've done is actually just tightened up some of the parameters. So we have a set of constants that then the rest of the code references indirectly through those constants, and everything else is exactly the same. Now, the move look controller is a little bit of an interesting case. And when you think about Windows Phone, some of the things that we would do on the tablet or the PC don't make a whole lot of sense on the phone. Like, how do you hook up an Xbox controller to the phone? Today, you can't, right? So that's one of the places that there's kind of this divergence between the platform. And so in this move look controller class, what we did is actually subclassed it and put the things which are specific to those different devices into the different instantiations. But then So if you look at the phone side, you'll notice that there's also on the phone, there's the ability to actually hook the hardware back button. There's no hardware back button on PC, so that doesn't make sense to have that hooked on the phone or on the Windows version. And then the code on the left-hand side is actually the Windows version, and that includes all the code that uses X input to be able to handle the Xbox controller. So if you want to look at those codes, and that's the only differences that we have between those two projects. So I think that's pretty cool that you can take that code and migrate it, and this didn't take very long for us to be able to make this transition. All right. So that gives you a little bit of an idea of what those universal solutions look like and how we go about doing them. And so again, I would suggest go look on MSDN, go download that code. It's live today, and you should be able to pick that up and be able to compile it and play around with it. So with that, I want to switch gears a little bit and talk now about some of the new capabilities that we have in 8.1. And we're going to start with the tech stack. So how many of you were here last year at Build? You probably saw this image. We talked a little bit about this from the context of one of the things that we've done as we've looked at text is that one of the places, and this is a screenshot from the Mail app, one of the things that we noticed was that there was a significant amount of resources that were taken to be able to do things like color emoji. And the reason is the platform didn't support color emoji natively, which meant that the only way to do that was to do bitmaps and then store the bitmaps and then, oh, well, DPI changes, so I need 3 copies of them to handle the different plateaus. And pretty soon, the size of the app and the performance of the app was pretty slow. And so in 8.1 last year, we actually introduced a new technology called color fonts, which actually allows us to do multiple colored fonts. So this is being drawn natively now to be able to support that and not have to have all those bitmaps and all those different size resolutions because it's just text. And text, as probably most of you know, 80% of the stuff that we draw on the screen on a frame-by-frame basis is text. So my team does a whole lot of work to make sure that text is fast. And the higher the DPI gets, the more challenging that is because the more pixels we have on the screen to draw for the same letters and the same sizes. So we're always in this continual mode of how do we make text faster, how do we get the performance to get you that smooth scaling factors and be able to pinch and zoom and get text to look beautiful. And so color fonts is a new addition which allows us to be able to use that same technologies and be able to now do multi-layered colors and get very nice looking color emoji at the same time. So let me show you what that looks like. And I'm going to go straight to the phone here. Is that one? So this is a sample. This first screenshot that I'm showing you is actually the color font sample. This is again available on MSDN. This one has not been converted to a universal project yet. We didn't push that one, but what we did do is I've actually updated this one to be able to show you a couple different things as well. So notice that we can scale in and the color emoji is actually part of the standard font fallback, which means that it just turns on automatically when you reference those glyphs. Now, the other thing that we can do is that we've actually worked with some of our Font Foundry partners and actually developed so that we can show you some uses of color fonts just from a font perspective. This particular font called Subway Color was developed by Ian Patterson of Monotype for us. This is another of Ian's creations. This is called Clickitat. I think that's kind of a cool looking font. And again, it's just text, but now we have color and we can do some very interesting things with it. Or even things like iconography to be able to use those from this font. Now, similarly, one of the other things that we think that there's a lot of power in being able to use the color font technology, and especially when you think about DPI and you think about devices of this form where, I don't know about you, but on my phone as I get a little older, I need to do a lot more pinching and zooming because stuff does, it's like, the font's too small, so I'm like, blow it up, shrink it down, blow it up, shrink it down kind of thing. If it's bitmaps, that's not going to scale well. But all of these are some custom icons that we developed using the same technology. And so you can see how now I don't need to keep track of a whole bunch of different sets of different bitmap sizes for different DPI. I just use the font. And there's actually tools available. I went and looked this morning, again, just to verify. There's a couple different tools that are available on the web today that allow you to actually go create your own color fonts. So if you're interested, come talk to me afterwards, and I can show you what those references might be. So I think that's a very interesting way to think about and approaching your UI elements and your iconography that you might want to put into your applications and give you a lot more scalability. Uh-oh. Can you come log me into this platform? The slides are now logged out. All right, we're going to keep going while he does this. So color font technology, we really think this is a powerful way to be able to not only do emoji kinds of things for text applications, but because the tech stack is so highly optimized and so highly tuned, then it really gives you the opportunity to be able to use that same technology to be able to do your iconography as well. Hit the arrow.
Do those color fonts support gradients at all?
Not yet. We're actually in the process of looking at what ways that we might be able to enhance those, but that's not, we don't have anything to announce yet in that sense.
Performance-wise, would you say that you create a set for an app that you publish, you create a set of fonts for all the glyphs?
No, what I would suggest is that what you do is that you create a set of fonts in the private range that would identify the things that you want, and then use just those Unicode values in place where you draw them, and that's how you turn them on. In fact, that's what we did with each of the glyphs for the UI elements, was just to turn them on that way. But that's a very good question. So from a standpoint of color fonts, it's available in DirectWrite and D2D directly. As soon as we get the slides back, I'll show you the code fragment of how you actually turn that on. It's also available in XAML, and it's also available in IE. So those technologies are... Okay, where's my slides? There you go. Sorry about this, guys. Okay, I think we're back to where we need to be. So as I was saying, color fonts are available in IE and XAML. If you, just by specifying things in the emoji range, for instance, they will automatically turn on. If you have your own special font that has color glyphs in it, then just make sure that that's in the, that you reference that as a part of the UI, as a part of the text text name, and that'll work as well. So these are supported through, in addition to the OpenType format, there are actually multiple layers. So if you don't have color turned on, you're just going to get the grayscale equivalent. We've extended the OpenType format. This is also in discussions with with the committees about accepting this in the broader standard. That's an ongoing discussion right now, but it's part of the proposed standard. It's still text, so it just works as I think I've already shown you. There are 2 new fonts. On the phone, it's actually called Sego WP emoji. On Windows and tablets, it's called Sego UI emoji. The fonts are actually slightly different. The decision on the phone was actually to put the white background around the outside because many of the phone styles actually have dark backgrounds, and so that some of the icons were disappearing. So you'll see some slight differences in terms of the way the icons look, but they actually follow the same glyphs. Okay, so what does it mean to turn them on? If you're using DirectX layout, so that if you're using D2D and DWrite to do the layout yourself, to do the layout for you, when you're actually going to draw it, all you need to do is add 1 additional flag, and voila, if there's color, it will turn on. How many of you actually use the lower levels of DWrite to be able to do your own layout? Anyone? Okay. So if you do that, one of the things that typically you get the glyph run and then you'd say draw glyph run. It's fairly straightforward. All you need to do is you say translate that into color. It'll give you the number of the layers, and then you just iterate over those layers, and the color is actually associated with the layer. You set the color for each one of them, and there you have it. So it really is just text. We're just pulling out, there's a new table in there that specifies what the layers are for the glyphs with the color associated with that, and good to go. So it's a pretty clean implementation from that standpoint. Okay, we're going to move on to geometry. Time. So 2D geometry. One of the interesting things about geometry, again, this is a place that we spend a lot of time analyzing what's going on in the graphics stack and trying to figure out how we can make performance as good as possible. One of the interesting things about 2D geometry is that it doesn't necessarily map directly to what 3D graphics hardware likes to think about, right? Graphics hardware, it thinks about points, lines, triangles. That's it, right? Textures and how you draw things on that, but from a geometry perspective, everything breaks down to that. When you think about 2D geometries, we have a lot more curves and Beziers and all kinds of interesting, much more rich set of graphics. But the problem is, to draw those on the screen, you still got to get down to points, lines, and triangles, which means that we have to do a whole bunch of CPU work to get that to be visualized on the graphics hardware, right? So complex geometry is very much CPU bound. Secondly, the existing technologies, when we look back to before Windows 8.1, the technologies that were available had some significant limitations. In particular, as you think about device form factors like the phone where you do a lot more pinching and zooming, the challenge is if you're using bitmaps, as soon as you start to pinch and zoom, then you're going to have to recompute anyway, because otherwise it's going to look blocky, and you're going to lose the effect of the fact that you actually have smooth curves, right? So you can create bitmaps, but as I said, those generate don't give you good rotation and scales, and they also can consume a bunch of resources and require you to regenerate. The other thing that's been available for a while in D2D is called geometry meshes, but those, again, were only designed for aliased and had some significant limitations. So there's a couple solutions. One, if you're on 11 hardware or 11.1 hardware, there's a new feature that was introduced in the hardware called TIR, which allows us to be able to generate geometry very much more quickly and do a bunch more work on the GPU side and eliminate a bunch of CPU work. One thing to be careful of is in 11.1 hardware and use this feature. It will turn on automatically if you're on 11.1 hardware, but you need to make sure that you set the fill rule appropriately, because the alternate rule does not turn on this feature because of the way that the graphics hardware actually works underneath. The second thing is what we introduced last year at Build is a thing called geometry realizations. And Geometry realization, I'm gonna spend a little time and go into a little more depth about how geometry realizations will help you, especially on smaller form factors where the balance between CPU and GPU can be a little more skewed, and so you wanna pull more of that work off of the CPU and push it more to the GPU because you have more cycles to be able to do there, and you want to keep the power burn that you've got going to a minimum as well. So geometry realizations, we introduced this in 8.1 on Windows. It's now available also in Windows Phone with the Windows Phone 8.1 release. And this really allows you to be able to amortize the cost, the CPU cost of actually tessellating that geometry frame over frame into doing that work once, and then using the GPU to do the work on successive frames. One thing to note is this does create a device-dependent representation, so we're actually going to create basically those triangle lists and all the data that needs to go with it and store those on the GPU. This does help us to minimize the CPU resources, and in particular, depending on how you actually implement it, you can do it once and then store that geometry. But there are some, again, if your geometry meets certain criteria, it's going to work great for you. If your geometry is changing on a frame-by-frame basis, well, I can't help you too much because you're going to still have to go do the tessellation again. All right, so what does this look like? If you think about what the process that we go through every time we're going to generate a frame with geometry, especially if it's straight lines, then there's not a whole lot of work to do. But as soon as you have curves, we have to do curve evaluation. And basically what the graphics stack does is to analyze those 2D primitives, figure out how we have to tessellate to get that curve to look smooth, even though it's going to be piecewise linear continuous under the covers, right? That's because that's all we can draw with the graphics hardware. We're going to tessellate it, then we're going to do the anti-aliasing and the brushing. That means either the filling or the stroking along the line. All that work gets done in the GPU. So with geometry realizations, what we can do instead is we're going to do that curve evaluation and the tessellation piece, and we're going to cache that into a new object, which you're going to create and hold on to. And then you can pass that back to the GPU on a frame-by-frame basis, and we can eliminate all that CPU work up front. Right? So we're just going to do the back-end GPU side and get the kind of performance that you want without burning the CPU cycles. Right? So now we're going to take the geometry and we're going to that geometry realization and just push it through on a per frame basis. So let's look again what that looks like. Let's see. Go here. The right one. Yes. Okay. So geometry realizations on this is running on a Surface, or actually Surface Pro. What I've actually done is taken the tessellation form, and we actually have a tolerance that allows us to be able to control how close to the actual algebraic definition of the curve we get, right? And so by forcibly modifying that, you can see how we break that value, and so we lose that perception of smoothness. So that's geometry realizations on Windows. Now let's look at the same thing and go back. Go. Come on, so there we go. Geometry realizations on the phone. Again, same code. This code is available. The slider tolerance is not in the sample that's on MSDN, but everything else is there. I've made some tweaks to this to change the buttons just because I thought it looked cool to be able to use. This is iconography. So you look at those buttons. Those are actually done with text. Good reason to do it. So geometry realizations running both devices. Again, unified projects. All right. So a couple questions you need to ask yourself about whether the geometry realizations will work for you in your applications. First of all, is your geometry relatively static? In other words, is it changing frame on frame in terms of topology or the way it's structured? If it is, then your geometry realizations aren't going to buy you anything, right? Because it actually probably spends a little more CPU time up front to get a better approximation because we know we're going to use it multiple times. So if your geometry really is changing, don't use geometry realizations. Actually, it can cost you more if you're changing it every frame. Secondly, when you're actually applying transformations to the geometry, right? So this will work on a range of scales and a range of translations, right? Because we're actually keeping the representations in triangles and points and lines. But if you're going to do non-uniform scales, that can be a problem because then, again, you're going to break that illusion that they actually have a smooth surface, right? So be careful of your scale factors. But pinch and zoom typically is uniform, and so that's going to work fine. So for most of the kinds of applications where you're doing interactive, sort of viewport changing, this is going to work great. The other thing to think about when you use geometry realizations is about the scale factor. So because this is a device-dependent representation, we're actually going to do the tessellation based on a tolerance factor that says the tolerance is the distance that we're going to allow to go between the arithmetic value of what the curve looks like and the actual approximation. And so typically what we would say is based on the current transformation, that's about 1/10 of a pixel. Now you can change that, but that's kind of the default. So you can imagine that as you scale that up, you can go about 10 times and still get nice smooth curves. But now if you scale down by 10 times, that means now you have 1/100th of a pixel, and you're probably drawing too much data, right? You're telling the GPU to do a lot more work than it needs to. So the demo and the sample that's on MSDN actually shows how you can do dynamic scaling so that within a range you keep that same scale factor, but as soon as you go above or below, you're going to regenerate the geometry at a different scale factor, which then says, oh, I'm going to use less triangles or I'm going to use more triangles based on the scale factor. Okay, so take a look at that sample. I think it's a great way to give you sort of that dynamic range and be able to do things. If you know what your scale factor is and it's a fairly narrow range, then pick something in the middle and don't worry about it, right? But if you want to have that much broader range of scale, then think about the dynamics. All right, so we're on the home stretch. We're going to talk about imaging now. And how many of you know what image effects are? All right, image effects. So I have another demo. I'm just going to go to the phone for this one. But this runs on both, within the sake of time. So turn it back on. There we go. So this is a demo that we put together over a couple days to be able to show off image effects. And this is actually a fairly complicated graph. Again, it's running on the 920. So all of the text is being drawn once, and then on a frame-by-frame basis, we're actually animating the effect to be able to get those flames to come out of the text. So let's take a quick look at what the code would look like to do that. And I'm actually not going to show you code, but I'm going to show you sort of a block diagram of what the effect looks like, because the code, well, we don't have time to go through the code. Basically, what this effect does is there's sort of two paths through it, or actually three paths through it. The bottom path, can you guys read that? Okay. This version, can you guys read the text on the boxes? Okay, good, because down here I can't see a thing. So the bottom path, the turbulence through the border, through the affine transform, that affine transform is actually the thing that's doing the animation on a frame-by-frame basis to make the flames flicker. But the turbulence is actually the thing that's doing the perturbation of the imaging and then the dilate and the color matrix across the top is actually taking the form of the text. So we render the text once into a bitmap. Then we do some transformations of that, and the color matrix is actually doing the shift from the white to the red and orange. And then the displace in the middle there is merging those two things together. And then the final affine transform and the crops, kind of those top and bottom two pieces, those go together because when we have multiple lines of text, because we're doing a stretch, we need to make sure that we actually position the effect on the baseline of the text. So we're actually running, for when there's 2 lines of text, we're actually running this, this image effect twice with a crop for the first line and the second line. Does that make sense? So what this, and so what we do is we draw image twice by changing the boxes on the top and the bottom to specify the clip rectangles to be able to run the image effect. We specify the image effect once, we build the image effect graph once, and then just on a frame-by-frame basis, we've already cached the bitmap. We're just doing draw image twice to be able to get the end and updating the animations. So it's pretty cool that we have that kind of technology that's now available on phone. I'm really excited to be able to say that image effects are there. That's kind of an interesting example. It's a fairly complicated graph, and you see that the frame rate is very acceptable from a performance standpoint. Think about image effects as being things to be able to do if you're doing photo apps, or you're looking at pulling images off the camera and want to do things like drop shadows, or you want to change the contrast. All those things are built into image effects today. So a great way to be able to go apply those. Also, if you want to write your own custom effects, write a little bit of shader code, you can actually do that and plug that into your effects graph as well. So one of the other things that we've looked at from an image perspective is, again, this is a place where we spend a lot of time looking at from a performance characteristics of what do we need to do to make sure that the platform is actually performing and give you the kind of performance you want from an image perspective. And one of the things that we've really realized is that as we look at applications and we look at the startup times and we look at the resource utilizations, one of the things we found is that a large portion of those, that both startup time and memory utilization is taken up by images. And so in 8.1 for Windows, we actually looked at how we can move the needle and to actually reduce the resource requirements and speed up image loading time. So one of the things to look at is when you try to figure out, well, how are we going to get a better compression ratio, and how are we going to be able to use compressed images as opposed to full scaled out versions, we have to think about what the quality versus space trade-offs look like. If you're familiar with JPEG, there's a couple different ways that you can do. There's basically a quality scale, and when you get better compression, but you can get more loss. So you have to think about where on the scale you feel comfortable with in terms of the trade-offs you make when you make those kinds of compression decisions. D2D now supports 2 different kinds of image compression. I'm going to talk about each of those in part. They're used for them in different ways, and so I think they're fairly complementary in terms of the ways that you might think about them from your application perspective. The first is ways to be able to use JPEG directly and use only partial decompression before actually moving it into the GPU. And the second is a thing called block compression, which we'll talk about in just a minute. So JPEG image loading is a fairly complicated, again, on the CPU process side. You have to go through all these boxes. You pull it off the disk, and it's great from compression standpoint, but the GPU doesn't understand anything about JPEG today. So you got to get it into a full-blown RGBA surface to get the graphics hardware to do anything with that. So in Windows 8.1, what we did is we said, well, YUV is an interesting sort of halfway step through this to this decompression stage. What if we sort of short-circuited the process and pulled out the YUV instead, and we created an image effect that will actually deal with YUV. So now I can push the luminance, which is usually at full fidelity, but is 8 bits per pixel, and then the chrominance, which is really the place that we get some of the compression. Depending on whether it's 444, 422, or 420, right? You can get some significant compression ratios there in terms of the amount of data that you need to push in. And your eye is much less sensitive to the chroma compression than it is to the luminance, for instance. Again, this is one of the places where you need to look at the image quality. But again, this is one of the things that you can plug into your application, take advantage of it, and actually reduce the amount of memory that you're using on your form factor. And it really, especially from a user asset perspective, this just kind of flows through. Where the block compression we're going to talk about next is a little bit different. So block compression formats. So how many of you are familiar with BC 1 through 7? Even know what that means? Oh, good, good. All right, block compression. Block compression is a way to be able to take blocks, and the graphics hardware actually understands this natively depending on the generation of hardware. It depends on which formats you can actually support. DirectX 9 and above hardware, supports BC 1 through 3. When you get to 10 and above hardware, you get 4 and 5 in addition to 1 through 3, and then for 11 and above, you get 6 and 7. For this discussion, we're going to focus primarily on 1 through 3, because this really gives you the breadth of all of the graphics hardware that's out there today, and you don't have to worry about, oh, well, what do I do if I'm on 11? If I'm not on 11 hardware, then you have to fall back to some other software path. The cool thing about block compression is this really gives you about 4 to 8 bits per pixel, as opposed to 32. So it really allows you to be able to pack a lot more data onto your GPU and use that without having to page data in and out. This gives you 87% smaller footprint, and because the GPU understands it natively, it doesn't say that we have to expand it when we get it to the GPU. The GPU can sample directly out of this format and use it natively. It is lossy though, and I'll show you what I mean by that. And again, because it's a block compression, it's actually a block that's 4x4 or 16 pixels at a time. Your images have to be on a 4x4 boundary. So let's look at what this means from just sort of an example perspective. So as we would compress this image, we would look at 4x4 blocks across the image, and for each 4x4 block, or each set of 16 pixels, we're going to look at that 4x4 block, and in the RGB space, we're going to pick 2 points. How you pick those is an interesting discussion all on its own, but the software does the encoding software that we have actually picks these points. And so basically what we need to do is find the best representative points for those 16 values that we can represent closely, those 16 values. Then we're going to linearly interpolate between those in RGB space. And then for those block of 16, we're going to pick one of those 4 values to encode it. So I hope you can see that where this becomes lossy. And one of the things to realize about block compression is that when you have synthetic images in particular, which have very sharp edges, if those sharp edges hit on the 4x4 boundary, you're golden. If they don't, or they're diagonal, you're going to get some pixelation, and you're going to get some loss in terms of the quality of the images. So just be aware of that. The colors that we store are those endpoints are 565 rather than 888. So you're also going to lose some fidelity in the values there on top. BC1, good for this is going to give you 4 bits per pixel. It's good if you have no alpha, so if it's completely opaque, or whether you just have 1 bit of alpha, so it's either fully transparent or fully opaque. BC2 and 3 allow you to actually have alpha values in there. Again, remember that D2D uses pre-multiplied alpha as a way that it uses on its pipeline. So my recommendation is the BC3 is probably the best form for using within the 2D pipeline. The color there is actually works better for correlated with the RGB values. And it does the same kind of approximation thing where the BC2 does it a little differently in terms of how it represents the alpha. So again, I would probably pick 1 or 3, depending on whether you have alpha in your images or not. Okay, so how do you use them, right? How many of you ever seen a DDS image? Oh, good. All right. So DDS isn't one of those things that you're just going to go to the web and go find a DDS image, right? This kind of format, it's not like JPEGs, right? JPEGs are ubiquitous. DDS or block compressed format, not really, right? So what we suggest is use your current authoring pipeline. Really, block compressed is really about the image assets that you're going to ship with your app. They're not about using them from a user if you're going to get user data. It's not something you're probably going to convert on the fly if you're taking images off the net, or you're taking them from a camera or from a device. But think about it, these are from the images that you have in your assets as a part of your package. This is the place that you think about using block compression. So use your existing pipeline, and then as a part of your, think of it as a runtime format. So use the pipeline that you already have. and then convert them to DDS as a part of the process for building your app, right? Generate them as a part of that. And so pictorially, it looks like this, right? Use your existing pipeline, create the image assets, then as a part of your build process, convert them to DDS, and then use them and package the DDS files. Conveniently, we've made this available in Visual Studio. So there's a flag that you can flip on and specify the right thing, and it'll actually take those assets and convert them into DDS directly for you. Again, when you do this, make sure you look at the images and make sure that the image quality is what you want, right? All right. So sort of a guide for where you want to think about JPEG and the YCBCR compression if you're going to modify your code to be able to use that short circuit path. JPEG, the YCBCR compression, use this for user assets. This is a great way to do that. IE is already using this optimization directly for most of the image pipeline. It's given them reducing their image sizes in terms of the memory consumption that they use, and giving them a performance boost as well. No conversion. You don't have to do anything as a part of the pipeline process. This is actually part of the decode is how we pull it out. You can get 25 to 63%, again, because it's even at 444, which means that you really don't have any subsampling in the chrominance. You're going to be using only 24 bits instead of 32 bits, right, to be able to get into the pipeline. So that's where the 25% savings comes. As you get to more compression in the chrominance values, you'll get to the 63%. On block compression, this is really about app assets. Do this as a part of your build process. This is, again, better for probably natural images than it is for synthetic images, especially when you think about sharp edges and especially if it's curved surfaces within those sharp edges. But you get much better compression on the GPU utilization. So if you've got a lot of assets and you want to pack those in onto the GPU and not get a lot of paging, then block compression really is something that you want to take consideration of. All right. Home stretch summary. So showed you what it means to have universal apps and how we've converged the platform from a DirectX perspective, from the graphics standpoint. On Windows and Windows Phone, the API surface really is converged. So that means all of the things that you've been building on Windows with DirectX, with D3D, with D2D, with DWrite, with image effects, all of that is now available for you on Windows Phone 8.1. And I'm really excited about that because I think that really gives you a lot of power to be able to take advantage of the GPU horsepower. And some of the things that we've talked about from a feature perspective actually give you more of those handles to be able to reduce the power consumption and the CPU overhead and costs that are associated with doing a lot of these rendering things. So from a text perspective, right, to be able to use color fonts, to be able to get iconography and to get rich experiences there. Geometry realizations from a geometry standpoint to be able to reduce the CPU costs, and imaging both from the image effects standpoint and from the compression. So here's what I suggest, right? Go look at the universal projects. Go get the RC for Visual Studio Update 2. It really has a lot of cool stuff in it, and the universal solutions are really I've been playing with this since before the beginning of the year in getting samples converted, and there's really a lot of cool stuff in Visual Studio. So highly recommend go learn about those, and it really will give you the ability to be able to move your apps and provide your apps on both platforms very seamlessly. Secondly, color fonts. I think this is a great addition to be able to use and to get iconography and to be able to get those rich experiences. From a geometry standpoint, geometry realizations, I really think, especially on the phone, is going to be a real win with the pinch and zoom and being able to reduce the CPU costs and move a lot of that computation to the GPU. And finally, image compression is, again, one of the ways that we're really moving to help reduce the resources that are required and get you the performance that you're looking for out of the platform. The decks will be online, so if you want to go look there, here's references to the samples. There are actually two the shooting game samples. They're actually derived from exactly the same code. The difference is that the XAML version actually has some additional capabilities to show how to do in-app purchases and deal with the store APIs that are tied in with being able to use the XAML UI. The first version, the DirectX version, only uses core window, so it has a much smaller footprint from an overall image standpoint. But the code that's actually for the game itself is all the same, is completely identical code. Color font sample is also available, and so is the geometry realizations one, block compression. The image effects one is not there yet. Finally, a couple talks. The top two have already actually taken place, but if you missed them, I highly recommend you go get them on Channel 9 and take a look at them. The third one is actually tomorrow. I think it's tomorrow afternoon. Rong is going to be doing a talk on Visual Studio and the cool debugging things that are enabled in this update. Again, I highly recommend that, and there's some really great stuff there. And so go hear her talk tomorrow afternoon. And finally, I'm going to be downstairs in the expert one-on-one sessions tomorrow from 1:30 to 3:30. So if you don't get your questions asked or you want to talk code and you want to go into more specifics, please set up some time, and I'd love to talk with you. So with that, also, we'd love to have you fill out surveys online. So zap that with your phones and fill out those surveys. And with that, I thank you for your attention.